Hey guys, how you doing? This is Charles here, welcoming you to this quick tutorial on RIP EIGRP and OSPF protocols. We have a simple network here with three routers. So I have used 2600 router series. I've also used 2900 switch series with two computers connected to each fast Ethernet interfaces. Now, to note, I have also tried to use /24 CIDR values, and as you can see 192.168.1.0, 3.0 and 5.0. So these are the fast Ethernet interfaces. This is where we're going to have our user bases, and 192.168.2.0, 4.0 and 6.0. These are the serial links between all three routers. Also to note, I have allocated the first two IP addresses to the router interfaces. You can call them gateways. So let's start with the configuration. So I'm going to start with the CLI. So I'm not comfortable with the web console. So CLI is always the best. Configure terminal, host name. So this is branch 1, and I'm going to try enable conflict branch 2, and the third router. Right. To proceed along, let's configure the interface IP addresses for the first router to start with. So interface FA0/0 IP address 168.1.1. That's the first IP address belonging to this network, and definitely give a no shutdown. Then the serial interface, which is serial 1/0. As you can see, this is 1/0 for the second interface. For 2.0 network, IP address would be the first IP address, which is 2.1. Definitely give a no shutdown. Clock rate is compulsory. And the next one is nothing but your 6.0 network. So 6.1, no shutdown, and clock rate 64,000. Right. So I'm also going to configure DHCP protocol for the fast Ethernet interface, which is 1.0. So IP DHCP pool. So I'm going to name my pool as 1. This is the first pool. This is 1, 2, and 5.0 is going to become 3. So pool 1, so network is nothing but 192.168.1.0. Do we need a network mask? Yes, we do. 2.0 for a slider value of /24. Default gateway. So default gateway is represented by default router in this. So it is 192.168.1.1. Oops, 1.1. Right. With DHCP done, the next step is to configure your RIP protocol. So I'm going to exit out of this. The command is router RIP. We're going to try version 2. Version 1 has been deprecated from, as you understand. So network 192.168.1.0. This is 1.0, 2.0 and 6.0 are directly connected to my first router. So I'm going to try 1.0 now. This is 2.0 and 6.0. With the first router being configured, we have to configure the second and third router. I'm going to show you an easy way to do so. So what you have to do is you have to copy this code, open your text editor or notepad in your case. remove anything and everything except for the commands completely, including the statements, including these incomplete commands. All of these need to be removed. So I have already completed this part, so it's going to take 2 to 3 minutes. So I have already completed this one, so I'm going to show you that. So let's work on that router. So once you sanitize the code, this is what you get. So this is what we have done with router 1. So I'm going to modify the same with respect to your router 2, and directly connected networks to router 2. So your fast Ethernet interface is nothing but 3.1 S of 1 of 0, S of 1 of 0. As you can see, this is S of 1 of 0, which is our 2.2 network. Sorry, 2.2 IP address. And S of 1 of 1, which is connected to your fast Ethernet, well, not fast Ethernet, but your serial link 4.0 network. So this has to be 4.1. We haven't used this network at all, so 4.1. And my pole for DHCP. So my pole for DHCP is going to be 2. 3.0 is the network. 3.1 is the gateway. And as we understand, 2.0, 3.0, and 4.0 are directly connected to this router. So 2, 3, and 4. So copy this code. Copy. So go to your router and apply the code. So the job is done. And you're pretty much going to do the same thing for the third router. So we are going to modify this code, all the commands with respect to the third router. So fast Ethernet interface is nothing but your 5.0 network. This is your 5.0 network. The first IP address is for your interface. And S of 1 of 0 is your 4.2. And 1 of 1 is 6.2. The pool is nothing but 3. So this is my pool for DHCP. 5.0 and 5.1 becomes my default gateway. 4.0, 5.0, and 6.0, as we understand, they are directly connected to this router. So these are the 3 networks that we can advertise. So 4.0, 5.0, and 6.0. So we're going to do the same thing. Control A, copy the code, go to the router, right click, paste. Let's just verify if DHCP is functional. So it looks like we have our IP addresses needed. So yep, so it's working 3.2 and 5.2, so it is done. So if you want to test it out, so you can add another computer. Enable DHCP in the computer. So it's going to take some time. It's not just going to distribute the IP address immediately. Let's come back in a while and we verify. Let's fast forward time a little bit. So this one, done. Okay, so we have the IP address for this particular computer, 1.4, and default gateway being 1.1. So this part is done. So this is how your RIP configuration works. And to verify connectivity, so I'm going to try to ping between these networks. So it's failed. Try again. So successful. So it's working. So clear this off. How about a ping from 2.0, 3.0 to 5.0? So it's working. And 1.0 to 5.0. So that is perfectly working. So it's all good. So the entire configuration is successful. What's left is the application of EIGRP and OSPF protocols. So in order to apply EIGRP and OSPF protocols, we need to remove the RIP protocol. So this is how you do it. Go to configure terminal, no router, RIP. You're going to try the same thing in the next router. So no router, RIP. The third router, exit, no router, RIP. Right. So let's get back to the first router, EIGRP. So you need to give an autonomous number. So I'm going to give a number 10, router, network 192.168.1.0. So we're still advertising the same network, 1.0. So we need a mask. We don't need a separate mask, but we definitely do need a wildcard mask. So wildcard mask for the /24 network is nothing but 0.0.0.255, and so apply the same for 2.0 network, which we are going to advertise, and then 6.0. So 1, 2, and 6. The second router, EIGRP, you need to maintain the same autonomous number, so that's mandatory. 192.168.2.0, 3.0, and 4.0. So 2.0, wildcard mask, 55. So that's successful. We found an adjacency, 3.0, and 4.0. And the third router, EIGRP. So make a note, we are using the same autonomous number, 192.168.4.0, 5.0, and 6.0. 194.0, wildcard mask, 55. Sounds promising. It's 5.0 and 6.0. Well, that's pretty good. Let's verify connectivity. It's working. Perfect. 1.0 to 3.0. So that's working. We are going to follow a similar sequence to apply OSPF protocol, open and shortest path first. So we're going to try the same thing. So in which case, you have to remove the EIGRP protocol that you have just configured. So no router EIGRP along with the autonomous number. So done. So do the same thing in the next routers. Exit router EIGRP and 10. Exit EIGRP 10. All right. So we have removed the routing protocols. So now apply OSPF protocol. So we still have to give an autonomous number. We can give a number between 1 to 65,535. So I'm going to try, let's say 20 network 92.168.1.0. Still the same network that we are going to advertise, 1.0, 2.0 and 6.0 for the first router. Do we need a mask? We need wildcard bits, 0.0.0.255. Are we done? No, we are not done. We have to set an area. So area comes with a process ID or an autonomous number. So I'm going to start, say, area 1. So now you have to note this point. OSPF 20 could be different between router 2 and router 3, but area that we have defined as 1 has to be the same. You cannot change that. So 1.0, so 2.0 and 6.0. Done. So note this point again once more. I haven't changed the area number. Area number is still the same. I haven't changed between the networks that I have advertised, and I'm not going to change the area in the next router that I'm going to advertise. And the command to proceed. So router OSPF 20. So you can give 30, which is not a problem. You can give 30, 168.2.0. Expand this. So 2.0, 3.0, and 4.0. So 2.0, the mask, your wildcard mask, and area 1. 3.0. Oops. 4.0. So done. And the next one, the third router, OSPF. How about we give an autonomous number or process ID 30? Let's see if it works. Network 192.168.4.0, 5.0, and 6.0. So 4.0, the wildcard mask, area has to be the same. 5.0, 6.0. Let's verify with a ping. Between 1.0 and 3.0, successful. 3.0 to 5.0, successful. And 1.0 to 5.0, that has been successful as well. Thank you guys. Thank you for watching this video. I hope I was helpful in explaining you RIP, EIGRP and OSPF protocol configurations. Have a nice day.